Moving on to the next technical session on aspect of die casting. For this, may I please invite Mr. Ranjan Swaroop, Director, Mrs. AgKASA Industries. I hope I've got that right. So may I please request Mr. Ranjan Swaroop to join us for this session? Ladies and gentlemen, he's just joining us here. Time right there.
20 minutes.
Thank you.
Yeah, please.
Ladies and gentlemen, you can see that the feedback forms are being handed out. Maybe request you to take this time to quickly just fill it out, take the opportunity, because we need to collate it, get it together so that we can then get ready for the lucky draw. This is the second last session. We just have one last session after this. Please note you have to be here in person if you want to win that. And we are not going to announce it once, twice, thrice. We're going to announce it just once. If you are not here, then it moves on. And if it's invalid, it comes to me. So if you don't want to be here, I would encourage you to not wait. Only because it'll come to me. No, but please try and be here because you've spent an entire day with us yesterday and today as well. We would definitely want the person whose name is called out to be here so that they can actually win this and take home an iPad. I'm sure that you'd enjoy it. And we also have the lucky draw time in the next, I think, close 45 minutes. So just be here with us for the next some time. And I'm going to hand over the session to Sir. He has about a few minutes, and then after that, we take another session. That's the last session for the day.
Don't worry. I have been up to so many things. So, good evening to all of the august gathering. I'm thankful to TAGMA, President TAGMA and EC, especially Mr. Amit Parashar, who invited me to speak on aluminum die casting. Last session I have heard about plastic, molding, additive manufacturing, plastic, mold life and lot of things. So after lunch and after that learning session, you may be feeling some boring. I'll show you some high technology video representing AI, IoT, additive manufacturing, molding, materials, composite material, navigation, system integration. Please play the video.
Customer pilots directed almost 3,000 precision strikes last year. We're super proud of it. It allows you to separate the bad guys from the good. It's a big deal. But we have something much bigger. Your kids probably have one of these, right? Not quite. Hell of a pilot? No. That skill is all AI. It's flying itself. Its processor can react 100 times faster than a human. The stochastic motion is an anti-sniper feature. Just like any mobile device these days, it has cameras and sensors, and just like your phones and social media apps, it does facial recognition. Inside here is 3 grams of shaped explosive. This is how it works. Did you see that? That little bang is enough to penetrate the skull and destroy the contents. They used to say guns don't kill people. People do. Well, people don't. They get emotional, disobey orders, aim high. Let's watch the weapons make the decisions. Now, trust me, these were all bad guys. Now, that is an airstrike of surgical precision. It's one of a range of products. Trained as a team, they can penetrate buildings, cars, trains, evade people, bullets, pretty much any countermeasure. They cannot be stopped. Now, I said this was big. Why? Because we are thinking big. Watch. A $25 million order now buys this. Enough to kill half a city. The bad half. Nuclear is obsolete. Take out your entire enemy, virtually risk-free. Just characterize him, release the swarm, and rest easy. Dumb weapons drop where you point them. Smart weapons consume data. When you can find your enemy using data, even by a hashtag, you can target an evil ideology right where it starts.
So this is not weapon. I would like to show that it's technology basically based on AI, based on IoTs, based on simulation, based on many things which we are using in our diecasting, tool industry, composite material, and so many things. I hope you like the video and must be agile now to listen my presentation. So I am basically a die casting person and spent my 28 years in aluminum die casting, especially in squeeze and vacuum die casting and Swaroop Limited for 7-8 years. I practiced it and come to a certain condition in die casting where can I guide people with tools and other things and process and so many things. So I start with Industry 4.0 and finally it will be Foundry 4.0 and it will be a automatic PDC cell, the final presentation. So everybody has spoken about all four industrial revolutions, steam engine, then assembly, then robots, and finally cyber physical system and smart factories. Word was coined in 2011 or 12 in Hanover in Germany, and 2015 in World Economic Forum it is being talked much, and from 2018 it is being spoken in India with a high speed. But still many of the factories have been turned towards smart factories using cyber physical data and so many things. But still we are lagging behind in such Industrial 4.0. I would like to draw your attention that Industrial 5.0 is following us. So, and we are not very near to Industry 4.0 even. So these are the pillars or the types of Industry 4.0, which I have shown in my video, that system integration, autonomous robots, Internet of Things, big data analysis, where Mr. Paresh has spoken about big data, cloud computing, that has also been spoken by Mr. Paresh. Additive manufacturing was highly spoken and machine was developed and parts are being made, which is highly recommended as well. Cybersecurity, a very important issue nowadays for each and everybody, not for industry, even it is for the households, it is very important. And cybersecurity is such an important instrument that the power grid was hacked in India for a few hours, and then it has been taken care from the cyber attacks. So cyber security is very, very important for coming technologies and coming future. And simulation has been talked about much in the last panel meeting. Simulation in plastic mold is being utilized and now very much common. But in pressure die casting, simulation is very much used nowadays. But my experience is this is only 60% correct. Rest 40% depend on your capabilities, on your experience, and on thorough discussions on the data, the result released by simulation. So it is digitalization of industry in Industry 4.0 is required to be done to take bottom-ups like PDCME, that is safety, quality, production, delivery, cost, morale, and environment means system. I have already spoken. Somebody was speaking about Industry 4.0 is not common. Yes, for tool makers it is different. For plastic mold it is different. For packing it is different. Like the one right solution does not exist. So everybody has to take care 9 pillars from Industry 4.0 and can devise it according to its use. So I'm talking about Foundry 4.0. Foundry 4.0, Foundry is considered to be blue collar job, and still in MSME area of India, the automation is not very much, or maybe 15%, 20%, maybe less than that. So high automation or low cost automation is very much required in MSME area, so that this MSME area of 6 to 15% can grow up to 50%, so that it can boost the economy to 5 trillions in coming years, which is the dream of our Prime Minister, to reach 5 trillion economy. So automation or Industry 4.0 or low cost automation, the initiation, that is very much required, very much happening, need to be done in industry. Foundry is, other than other industries, foundry is such a industry where lot of defect and rejections is happening, and there are potential losses. The use of these Foundry 4.0 taken from Industry 4.0 can take care, can simulate the process, the whole automation, can better the outputs and better profitability of the organization, then they can grow and adapt profitability further. I have spoken about profitability. Profitability can become only applying small changes, automation, SMED, low-cost automation. Then the bottoms can be up and foundry can be benefited. Pressure die casting can be benefited. I still understand, even after simulation or CNC machine availability, the die casting is still a black magic, still to be understand process. And nobody can get up to 100% of a good products or okay production from pressure die casting. Blowhole are bound to come, and we need to do something in that area also. So this automation derive us to better decision, better parts, better margins, better profitability. So everybody, one of us or factories or a small scale industry or even bigger industry of 100 crores and more than those, die casting industry must go for automation in that area. I have been experienced in getting training in Toyota, Japan for in pressure die casting company in automation. I share my experience to you that they were running 2 molds on a single machine. That molds were changing in every shot. That rails were there, molds were going inside the machine. sleeve was assembling into it, shot was taking place, the sleeve was unassembled, mold comes out, and the part is taken by dummy die casting machine. That means to say the value-added activities, the role of die casting machine to hit, and that is going to pay you, or that is going to give you die cast, the product value. But the die coat, spraying error, or extraction of the casting is not the work of the machine. So Toyota has devised this machine, and that machine is still with them. This is not open to anybody in the world. They have used the die casting machine people and developed that kind of machine. Such kind of automation is being taken care 10, 15 years before. So we are far behind in that area. So data, if we talking, Paresh sir was talking about data science. So data science, and you can visualize on your telephone. So data science, all the data in an PDC or foundry can be taken care, they can be taken, and this can be according to algorithm that can make some results. That result can be given to you, which you utilize and take decision. So decision making can be easy if you completely take care of data through algorithm and through softwares and so many things. So digital transformation, digital analytics, lot has been talked about digital data analysis, digital science, and so many. So data analytics, once again, how does it work? A big data analytics, cyber physical system, the component-driven production, flexible production system, and Internet of Things. All these 5 components work together and get you a better results. These are real-time definitions. If we get real-time data, like in pressure die casting components, whatever you produce, you get your results after or in your next process. What will maybe the internal defects. So real-time data, if we can get in pressure die casting components, then it will be easy for us to correct the machine, to stop machine from making defective products, which is nowadays not available in anywhere in the world. I think so. So this is foundry resource planning. It's a part of Industry 4.0. This is quality aspects. And so this is die casting system I would like to discuss with everybody. All theories, things I have just surpassed to control my timings. In a die casting cell, raw material comes, and when raw material comes, that could be in an automatic cell I'm talking. So when you place that raw material near furnace in a CNC die casting machine, then there is a linear robot which can take your ingots, put in the furnace. The furnace, the raw material area will be monitored by load cells, by color coding, by other things, that the raw material, when raw material finishes, the notice goes to RM supplier that raw material is being finished at near furnace. He will supply it, and I'm talking about complete loose system in Industry 4.0. The furnace part, it is melting in the furnace. There is a load cell, there is a level indicator which tell you how much quantity is in the furnace. And now the CNC machine, which is complete CNC machine, will take care of all complete feedback in the shots, the pressure, the speed, the level of all parameters, everything into it. Now the casting is taken by robot. The casting is extracted, and casting after casting extraction, the overflows are removed over there, and the casting is being subjected to press or a circular saw, so that the runners will be there, and the overflows will go back to reverse conveyor to again furnace. There will be a sensor to monitor the return ratio of the metal with the ingots. After runner cutting and overflows, further casting goes to a transfer line system where small machines are there which do fettling. All fettling stations are hop mechanism with sensors and pick and place mechanism, which will do automatic fettling, removal of parting line, drillings, removal of extra metal from the machine. After fettling, those casting goes to a shot blasting machine. Simple shot blasting, which will be machined in your cell through conveyor. Those shot blasted beams, again a pick and place robot will be there that will take casting, shot blast it, again put it there, and from there casting, the casting is inspected through cameras, the dimension and the internal through X-rays, and finally to packing place where pick and pick robot over there, which will pack into boxes, and boxes again transferred to the finished good sections, and from there it can be shipped to the customer. That complete cell can be done. Many of the parts we have done in Subros, in our working as well over there. I'm just finishing it. Finally, I would like to show Finally, I would like to show you that this is robot presence per 10,000 employees in the world, where Singapore has 918, South Korea is 868 per 10,000 employees, and Japan, Germany, Sweden, and US, and India is maybe 5 or less than 5. So robots are not very much familiar in the industry. Even pick and place robot for CNC or VMC machines are not being utilized in the industry very much. So this is the end of my presentation. Thank you for listening me attentively. If there is any question on die casting or anything, I'm ready to answer. So no questions. Thank you very much.
Thank you, sir. Sir, may I please request you join us center stage? Thank you so much, sir, for that presentation and for sharing your thoughts with us here. May I please request Mr. Parashar to join us on stage to hand over the memento? Ladies and gentlemen, please join me in thanking sir for his presentation. And if you would like to connect with Mr. Swaroop, he's going to be outside during the networking sessions also here. So if you have any questions, please feel free to connect with him. Thank you, sir.